A lot of you guys have asked about how can you effectively pre-study? How can you look at the content before seeing it for the first time in class or in lectures? This is really around the idea of scoping out your subject, and there are a ton of benefits for this, which is why this is more of an advanced technique that you can only really fit in if you are not cramming already. Without at least bare minimum average study techniques, you won't even have the time for pre-study, but pre-study can save you a lot of time. Essentially, 1 hour of pre-study saves 10 hours of studying later on. So let's get into that. Hey guys, welcome back. If you're new here, my name is Archer. I'm a second year medical student, and on this channel we focus on learning how to learn so we can spend our time on the things and people that matter the most to us. I never really quite knew how important pre-study was. I actually thought that it was a waste of time. I always thought that it would be just better to go through the content when I see it in class. But after realizing what the research sort of said about this, then I knew I had to change how I looked at this. So in this video, we're gonna unpack why you should definitely be doing pre-study and why it's important, what effective pre-study looks like in comparison to just normal pre-study, and then the much more highly advanced applications of pre-studying, which you can only really be able to do if you got the basics down. Okay, so let's get into it. So pre-study is not actually early studying. So that's the biggest differentiator that I just want to make right now. Early studying is effectively just going through your textbook or whatever resources you have and learning it before seeing it the first time when it's actually taught to you in a class or lecture format. Now that is useful because you would have seen it and had some time to process it on your own terms, but it isn't necessarily the most efficient use of your time. And this is particularly why in year 12, I didn't do any sort of pre-study or early studying at all. I would always see the information for the first time in class. However, there is an exception to this. I actually wasn't going to class quite a lot, so when class would go through it, I would just go through it on my own. But I didn't do any of this sort of stuff where you like study 6 months ahead or do the whole year 12 course in the summer holidays just before year 12 even begins. To me, it just seemed kind of ludicrous and a huge waste of time when I knew I could just go through it at the same pace as everyone else, but instead learning it on my own, essentially. And I'll sort of get into that as well. So the difference is, with pre-study, what we are really trying to optimize for is this thing called structural priming. As you probably realize now by going through some of my videos, it's really based around relationship building between different pieces of information and concepts. That's why mind mapping is such an important thing, which I really want to make my video on soon. So the way that I just want to kind of explain pre-study is, imagine that all the information that you're learning is in a book form. So essentially, for every piece of information that you have, you're gonna have books and books and books and books of knowledge. It would be okay to stack those books up and up and up, and you would have a pile in it eventually. But the problem is, if you wanted to recall a piece of information from those books, you're gonna have to take off the top, grab the book that you need, look at the piece of information that you need then, and then put it back and then chuck the pile back on. Hopefully you got that image. But essentially the idea is that it takes a lot of effort and it takes a lot of time as well to get to the piece of information that you need to recall. Compare this to having a bookshelf. I mean, this is why bookshelves are invented. Piles of books are disorganized. So if you're gonna have a bookshelf, not only can you organize it, but it's a lot easier to access those pieces of information that you need at any time. So how does this relate to pre-study? The idea is that pre-study is effectively creating that bookshelf before you go ahead and put all the books on the shelf. The big thing again is that pre-study should not be a huge use of your time. You don't want to go ahead and learn the nitty-gritty details of a particular concept when you're doing pre-study. If you feel that you're doing that, then you're actually just doing early studying, which is not what you want to be doing. So in any way that you can create this bookshelf is a good thing, and we'll kind of go through that as well. But I always, again, thought that this was just complete waste of time, but after doing it now and having a lot of my students try this out as well, it's just been a huge thing. And I'm not the first person who's done this as well. I've obviously found this in research and found a lot of other people who are using this as well and finding success with it. And essentially the stats are showing that 1 hour of effective pre-study when you learn how to do it can save you 10 hours later on. Because if you think about this structural priming, you are priming your brain to build relationships quicker. Instead of you having to stumble upon them on your own when you've already learnt the content in class for the first time. So being proactive, and again, part of active learning, in doing this yourself at your own pace, using your own questions and curiosity, you can save a lot of time with this. Okay, so let's get into how we actually do it, and I'm going to show you with an example as well. So here is a quick look at my cardiovascular block that we're doing right now in physiology. So what I've done is, knowing the content that I'm going to be going through by looking at the learning objectives or whatever sort of curriculum that you have out in front of you, you can see what you do need to go ahead and learn. Luckily for me, I do have access to the lecture notes, but for people who might be in school or don't have that luxury, you should still have learning objectives somewhere before the lessons even occur. Now, even if that isn't possible, because of how effective this can really be, even if you do have to fall behind in lectures so that you can go ahead and do this, that is a useful thing as well. If your schedule kind of allows for that though, if you get what I mean though, because you know, sometimes you might have tests on that week, so you need to be up to date with the lectures. So I mean, let's just break it down. So I'm going through my lecture notes, I'm looking at the textbook as well, and seeing how can I break the cardiovascular system into a smaller chunk. And one of the things that's super duper important here is the idea of chunking. A lot of you have probably heard of chunking within psychology itself if you've done any of that sort of stuff, but it's the idea that we break one big concept into smaller concepts. And you do this all the time anyway, and your brain just wants to think in this natural way. It wants to chunk things together. So in your phone number, for how many digits that really is, you're not gonna do it in 10 digits or whatever, but you're gonna try and break it down into 3 digits or 4-digit groups. And that's just a lot more approachable and easier to deal with. The same thing happens when you're going through content. You need to be doing this, otherwise you're just gonna make your life harder for you. I mean, there's a lot of people who just write linear notes where they're just going top to bottom down their page, but this doesn't have chunking involved at all. It has the tiniest bit when you have a heading and dot point, but that's just, you know, highly ineffective anyway, just because you're not having any of that relationships being built there. So if we look at here, I've got my heart, I've got my circular tree system, and then I can break them down into even more and more concepts that, you know, fit underneath these headings. So what you can see is that I've created a preliminary hierarchy of how I think each of these concepts are going to come and relate to each other. Keep in mind that when I am trying to figure out what goes where, I'm only looking at it in just enough detail to know what inflow stage is, to know what isovolumetric contraction is, and how that might potentially fit in the 4 phases of the cardiac cycle. The thing that's really important here as well, which saves you a lot of time, is that you don't have to be right at this point. You haven't spent all the time learning and studying it in a lot of detail, so you're not gonna know everything. But again, we're doing this to create some more structural priming so that it becomes easier when we do figure out where some of these things join together and fit. And it's just a noticeable feeling that you'll find when you start trying this out and then you get towards studying. But as you can see, for content like this, I do have a lot of things that are incorporated with each other. So it's important that these are chunked so I can see where they're coming from. For example, a lot of people fall into this trap with any type of subject that there really might be, where you focus too much on the microscopic details, but you don't even know where it fits into the big picture. So for example, here we've got troponin, tropomyosin, and sarcomeres. But you might know how all of this sort of works with the sliding filament theory and all this sort of thing, but you didn't even really know how it plays part with, you know, calcium, the muscles, the heart, and all that sort of stuff as well. Another example that I like to think about is a lot of people are learning about DNA and proteins in biology, but don't even know how that's helpful with body systems. And a huge thing for maths is a lot of people know how to do the maths, but I asked the simple question, why do you learn calculus? What is calculus important for? And they don't even know the answer, which means you don't even know how this fits big picture. And again, it's this huge thing about being able to zoom in and zoom out of the content and be able to understand it at all levels. You want to know how it works microscopically, but why it's important macroscopically as well. So usually how this looks for me at a university level is that I might have something like defined cardiac output. So I'm just going to straight away put it into my textbook and see if I can find where that sort of portion is being discussed. And then when I find it, I'm going to incorporate some inquiry-based learning here. So firstly, I want to know, why is cardiac output important? Just at a preliminary stage, I don't need to know the whole reason why. So I can see that it's a measure of cardiac performance here. So that makes it easy enough for me to know that this is a way to think about how our heart is functioning. But I can also see that there is parts of the cardiac cycle here, so I'm probably going to put it underneath that, which you can see I've just done here by putting it in the laws and calculations area. So sometimes I can't find it quick enough in the textbook or lecture slides or anything like that, so I'm just going to straight up ask Google, which is a huge thing that's super duper important anyway in studying as well. So what is cardiac output? And it tells me what it is here, the amount of blood the heart pumps through the circulatory system in a minute. Then with that inquiry-based learning, I know what it is now, but why is it important? Why is cardiac output important. And this tells me why it's relevant for me to learn this. Instead of just me knowing that I need to know this to pass my exam, I can make it relevant to me. So that's just a quick example of this. After all of this, you want to verify the hierarchy that you've created for yourself. And I do this in Notion, for example, but you can write this down. That's just fine as well. And you can confirm this either with your lecture slides or in class when it's happening in front of you. And you can go ahead and do your sort of notes. And the more effective type of note taking that I've always been mentioning for the past few months now is mind mapping. And you can see how this relates to it really well, because mind mapping is all about chunking and all about these relationships. So you do go from the heart to the circulatory system down to the distribution of blood, physics, cardiac cycle, muscles, conduction system, all this sort of thing as well. And you branch out. So if you're already mind mapping, this is going to work really well for you to just add on top. But if you're not quite up to mind mapping, still think about this in the back of your head when you're writing down your notes. But eventually you do want to start thinking about converting over to mind mapping, just because there's a ton of research that's backing it up now. The biggest thing I just want to highlight again is that you do want to prioritize this pre-study. I basically won't go ahead and learn anything else now without doing this pre-study, just because I know how important it is in saving me time in the future that could be potentially wasted, and me hoping that I'm going to eventually create this bookshelf for myself over time. And not only over time, but accidentally, just hoping for it to occur. Okay, hopefully that's all good. And if you have questions, make sure to chuck them in the comment section below. But now I want to touch on the very advanced applications of this. Now, if you're quite comfortable with this idea and you've played around with it a little bit, you can start to bump this up. And as you probably noticed, I do have a lot of content within this particular pre-study session. That's because I've been doing this thing of syntopical reading while making this up. The idea is that I've been learning a whole area of study, and essentially I've been doing 4 lectures at once when doing this. The point of that is if I'm doing a larger amount of information at once, I can see some more of those relationships without them being hidden to me. If I was just doing 1 lecture at a time, there might be a lot of concepts from lecture 1 that bind to lecture 2, but I haven't covered lecture 2 yet, so I'm gonna have to wait to make those potential relationships. So being able to do a whole area of study at once, I'm actually able to save a lot of time. Mostly because the more that you know, the easier it is to learn other things as well, which is that idea that, before learning calculus, you need to know algebra. To know algebra, you need to know counting, and early maths as well. It's the same idea again and again. So the reason that this is more advanced is not only are you dealing with a lot more content, you do need to be pretty efficient with it and make sure that you're not going into the very small details of these concepts. Otherwise, this pre-study session is just going to take you forever. For me, it only takes around 30 minutes to go through 4 lectures worth of content to pre-study it. But keep in mind, I do need to spend some more time to go ahead and actually study it. Pre-study is always going to be shorter. The easiest mistake to make is to spend too long on pre-study because you're actually just diving into the content. So just watch out for that. The reason this is also more advanced is that you're going to be jumping around all over the place because you're letting your curiosity rule. You're letting it ask, okay, you've learned about the cardiac cycle, what might be related to that? And then you go ahead and look at that. And then you see, okay, this might be related in this particular way. Then you do the next thing and then the next thing. And the more that you can try and create these relationships in the beginning, the more time you'll save, a lot more in the future. The mind mapping video is coming, guys, so make sure to like and subscribe and let me know what else you would like to see. Thanks again for watching, and I'll see you guys in the next one. Bye-bye.